based upon the number of users. Suppose if it is a city, for every 10 kilometers there may be a tower. If it is a village, there may be 50 kilometers there may be a tower. Every 50 kilometers like that. So we have GPRS, this is specifically developed. We have GSM initially, and taking care of the internet, they have developed packet radio service. So in the internet we use to send data in the form of packets. So they developed GPRS. Then they introduced CDMA, code division multiplexes. Based on coding, you can transmit data. I will talk about this in the coming slides. The basic wireless LAN is, this is the standard, 802.11. So it refers to, there are basically two categories. One is called infrastructure mode and infrastructure-less mode. What is infrastructure mode? If a node wants to send a data, it cannot send data directly to this node. It has to send data to a centralized point. From the centralized point, the receiver will receive. This is the infrastructure mode. Like mobile phone. If you want to make a call to, I cannot directly call. I have to make a call to base station. Via base station, it will go to BTS, MSC, all those. Then again, it will route it back to your destination phone. This is the infrastructure-based network. Okay. If you want to communicate directly, suppose I enable Bluetooth in my mobile phone. If you enable Bluetooth, we can communicate directly. There is no external infrastructure necessary. We call it as infrastructure-less. So infrastructure-less, still we have a lot of problems. Suppose if we open the connection without any centralized authority like base station, what will happen? If the other person is insecure, he is a person who can attack, our data can be easily attacked. So moreover, suppose he is moving out of the range, I cannot communicate. So I have to pass my data to another person and another person has to forward the data. I have to depend on the intermediate persons. Again, there is a lot of issue. So the mobile devices have power constrained devices. Power constrained means what? We cannot waste the power. If it is a computer, it is not a live power, no problem. Still you can always run because it is not a constrained device. Suppose if it is a mobile which I am not using, I have to switch it off or I have to sleep mode for saving my battery power. So this is the major constraint. So if I want to send data in an infrastructure-less network to a destination via other nodes battery also will be drained. So you have to carefully choose the nodes. You have to be cooperating with each other. So a lot of issues are there in infrastructure-less. Infrastructure, the only thing is you have to invest more. If you invest more, you can be able to get. That's why the mobile users are charging us for making call. If it is a infrastructure-less communication, there is no need for charging. Because we are using our phone, we are using our battery, we are charging our battery, we are communicating. There is no need for paying to anybody. But if it is infrastructure mode, you have to pay. But they will provide security. If we both are talking about healthcare. So the limitations in mobile environment, I said various advantages of mobile environment. Limitations are little communication bandwidth, so I said data rate. The wired environment bandwidth is more, wireless is minimal. Frequent disconnections, yes. If you are moving away, suppose if I am using mobile phone where there is no signal from the tower, I am just moving away from a tower so that I may not get signal. That is another problem. Heterogeneity of fragmented networks. What is heterogeneity of fragmented networks? I may have subscribed to a particular vendor like Vodafone or Airtel. If I move from one place to another place, that service provider may not have service there. I have to depend on some other vendor. So this is called heterogeneity of fragmented networks. So different roles, different players will play the role. They all have their own union, so they will provide us service. Limitation because this is about network point of view. In terms of mobility, yes, we already discussed there are a lot of route breakages, lack of mobility awareness by systems and applications. So we are moving here and there, but our system may not be able to understand our movement, how it is to be traced. Applications running in the mobile phone may not be able to identify. Limitations of the mobile device, yes, the device itself is having a lot of problem. We have shortage of battery power. Another thing is limited capacity. I cannot run the programs which I am running in this machine in this mobile phone because everything is constrained. Even the screen, processor, memory, everything is little compared to frames. So these are limitations of the mobile environment, but still we have to develop services catering this limitation. These are all the topics which we have discussed and represented in another form. We have locally network, wired network, internet is the mobile IP extension. We will discuss about mobile IP in detail. Now, with respect to wireless, since the medium is shared, cooperation is very, very important. Here it refers to regulations of frequency. What is frequency? You know what is frequency? How different users are sitting here under a particular base station, still they are accessing their mobile phone. Somebody is calling you, only you are receiving the call. You have all are access to the base station. How it is happening? Because every base station will be allotted with their range of frequency. You know what is range of frequency? For example, 900 to 935 or GSM. This is the range of frequency over which you can communicate. If it is a base station, we call it a cellular network. Means what? The base station will be there, it will be having a region of coverage. In that region, you can use multiple frequencies without coinciding with each other. In the sense, let us take frequency F1, frequency F2, frequency F3 for example. If I place frequency F1, if I place frequency F1 here, F2 here, F3 here, this F1 is far away from F3, so I can put F1 here also. This is called frequency reuse. I can reuse the frequency in a cellular environment, thereby if I use F1, where she is hearing through F1, since the neighbor frequency is F2 and another frequency is F3, the third person who is far away from F1 can use F1. So different frequencies can be used within the range. We call it as frequency reuse, that is used in cellular networks. So as per the regulations given, that is 900 to 935 for uplink and 890 to 910 for downlink. So we have to use those range for uplink and downlink. You know what is uplink and downlink, right? Sending data to the server and downloading data from the server, or calling and receiving, both different frequencies with a guard band. You know what is a guard band? Guard band is the band which separates the uplink and downlink frequency. Thereby there is no coherence. So bandwidth delays, low transmission rates, few kilobytes to some megabytes. So here, if you talk about transmission rate in wireless environment, it will be starting from few kilobytes to megabytes. Whereas in wired environment, it starts from megabits. Now we have gigabits networks also, fast Ethernet, gigabit Ethernet. They are all transmitting data in gigabits. So higher delay is because of several switchover. For example, one base station to another base station, there are various hierarchies, BSC, BTS to BSC, BSC to MSC, MSC to another MSC, MSC to gateway MSC, gateway MSC. So this is the hierarchy of transfer. So it takes some time for transmitting the data. In wired environment, we don't have such delays, but we may not immediately feel the delay, but actually it is doing a lot of hops. Higher delays, higher loss rates. What is higher loss rates? As I already said, wireless environment is susceptible for error. Always shared medium, lower security, simple active attacking. Radio interface accessible for everyone. Secure access mechanisms is important. So radio access is what? The wireless environment is access to every user. So you have to provide proper security. So this is the landscape of the current wireless technology. We have indoor, outdoor, mid-range, long range and long distance. So based on that we can use the different standards with the different data rates. This is the statistics we can see. Okay. Now, if you understand this, this is a simple mobile network model where do you think from my mobile to your mobile the entire communication is wireless? I am making a call from my mobile to your mobile. You are receiving my call. Do you think the entire communication, that is the data from my mobile to your mobile through the full path, is wireless or somewhere it is wired?
Somewhere is wired.
Where? Wireless is only between the tower and your mobile phone. From the tower, it has to go to the base station controller, then mobile switching center, gateway mobile switching center. All those communications will be fully wired. Why? Because from my mobile to the base station, I am not sending large amount of data. Only thing is I am doing voice communication. For voice communication, 30 kbps data rate is much sufficient. Or I can send some data like image or video that will be sending in a small data rate, less data rate. But what happens if many users who are sitting under a particular base station are sending data to the base station? It has to be sent as a collective data to the backbone network. So in the backbone network, if you use wireless or data rate is increasing, error rate also will increase proportionately. So we cannot send large amount of data in wireless environment. In wired environment we can do. That's why backbone network will be having fiber optics communication. all fiber optic cable. Only thing is, from my mobile to the base station we have wireless. So this is the diagram shows that I have a backend server, I have a mobile phone here, using the signal I am communicating with the base station. So base station to mobile phone, it is wireless medium. So once it reaches, it will pass on to a medium which is connected. Here there is no medium connected, it is a radio medium, here it is a connected medium. So effect of mobility and protocol style. If I move from one place to another place, how this movement will affect the behavior of the protocols in each layer. So we have basically 5 layers: application, transport, network, link, physical. So which layer is having more major role in handling mobility? Out of this. Yeah, of course network layer will have to address for addressing and routing. Okay. The main layer is link layer, because link layer is linking the actual device data with the channel. So you have to interpret the data in such a way that the channel, suppose if I am using a particular encoding scheme in the physical layer, so the link layer has to send data in that format. Suppose I am using CDMA or PDMA or FDMA or whatever technique I am using in the lower layer, that is the physical layer. The data link has to support data in the same format. So these two layers are very, very important in wireless environment, because based on the technique we are using in the lower layer, the data rate will vary. I am also using the same phone, you are also using the same phone, but how the data rate changes. Suppose if it is wired environment, based on the type of wire or type of technology which you have subscribed or you have paid, the data rate will vary. But if I am using a mobile phone, you are also using a mobile phone, the medium is common for both. But how the data rate for my mobile phone is different from your mobile phone? I am using GSM for example, your phone is CDMA phone, or I am using OFDM technique. How the data rate changes? For wire connecting, I am connecting a wire. Your mobile phone is connected with the same wire. Data rate is same. But if I am using a mobile phone is CDMA technology, your mobile phone is OFDM technology, or you are with FDMA technology, how the data rate changes? It is based on the technique which you have used in the phone. For example, if it is CDMA we have different data rates. If it is OFDM, it has higher data rates. OFDM is the highest data rate because it follows MIMO technology, multiple input, multiple output technology. So here, if it is FDMA, it has its own data rate. That's why in the lower layer, we cannot say a particular data rate. The data rate depends upon the technology which is used in the physical layer. Rest of the layers are same in both wire and wireless. Of course, this network layer will take care of routing. So perspectives means there are different people who view the network in different way. One is the network designers will think how to design a network with less cost. For example, I am like Vodafone or Airtel, I am going to start a new technology, and then I will think how to efficiently utilize the existing infrastructure. I cannot lay from the scratch. If I lay from the scratch, I have to invest more. So I can pay some money to Vodafone. I can use their infrastructure, but I can have my own service. This is the network designer. Need to ensure the network is efficiently utilized and fairly allocated to different users. Network users concern the application service. It guarantees the message sent will be delivered with the error within a certain amount of time. As a mobile phone user, what you will think? You won't think about what technology is used. You will think about whether it is sending the data without any error or how fast it is transmitting data. You won't bother about how it is working. Whereas network designer will think about how, with less cost, I can construct a network. Whereas network providers concern the system administration, how to administer the system. For example, if there is a problem, if the mobile user is traveling from one place to another place, whether he is receiving the signal or not, that plays a major role. I am having full functionality with Vodafone, for example. If I am moving out of Chennai, if there is no signal till I reach Bangalore, nobody will prefer Vodafone goes for traveling often from Bangalore to Chennai. So likewise, the perspectives of users will vary. Now this is about frequency, radio frequency issues like factors of wireless system design, frequency allocation, what range to operate. So what is the range I can allocate for the user? Multiple access mechanism. You know what is multiple access mechanism? That's what we discussed. So we are all in the same medium. We all are competing for accessing the medium. We have some protocols. Can you say protocols which used for multiple access in wired medium? There is a wire. I have connected multiple systems with the wire. It forms a topology. Let us take a bus topology system. Can you tell which mechanism we use for accessing this medium? Question put is that a common line is there, multiple systems are connected. These systems want to transmit data in the common medium. Whether it can transmit that as and when it has data, or it has to check whether the medium is free or not. Whenever there is a term called multiple access, you should not send data immediately as and when you have data. If you say not like, if this path is allotted only for me, if I want to go there, I can straight away go without bothering anybody. Suppose if I want to enter into a bypass from outside, what you have to do? Already there may be some vehicles moving. You have to check whether already there is a vehicle. If there is a vehicle, you have to wait and you have to enter. That's why it is called multiple access mechanism. So it uses, have you heard this? Aloha protocol starts from Aloha. We have CSMA, carrier sense multiple access, carrier sense multiple access, collision detection. Yeah, in wired environment, we can have CSMA CD. CSMA CD, carrier sense multiple access, collision detection. That means sense the carrier before transmitting data. If the carrier is accessed by many, that is the first point. If many are accessing the carrier, you don't transmit data immediately. You have to wait for the medium to be idle. If the medium is idle, then you can transmit. This is simple logic. Whereas here, in wireless environment, we cannot apply this carrier sense multiple access collision detection because we cannot detect the collision. I will tell the reason, because there is a problem called hidden terminal problem. We cannot detect the collision. We can avoid the collision proactively by not sending the data whenever somebody is sending data in the communication range. I will show one slide which says how CSMA CA is used there. Antennas and propagation, of course, in wired environment there is no concept of antenna. All are cable, but here we need some transmitter and some receiver, or we need a transceiver which can do both transmitting and receiving. So we have different types of antenna, omnidirectional, bidirectional. We have a number of types. Signal encoding. You know what is signal encoding? Encoding is signal. It means what? Connecting. Protecting signal. You have marker. Go to the for transmitting this bit, how to represent the form of a signal. Or a bit of data, I want to send 1. Is there data? How to send this one? We can represent 1 as a digital signal as positive voltage and 0 as negative voltage. Positive and negative. If you always transmit data in the form of positive and negative, in the form of positive upper edge and lower edge, if I have a continuous ones of data, if I have to transmit continuously once, 1, 1, 1, 1, 1, it will be a straight line. It will be a straight line. So what is the problem if I transmit a straight line? Straight line and a high voltage pulse. Always high voltage pulse. It is like a DC current. It is like a DC. DC there won't be an alternating. It is a straight line. DC is highly susceptible for external interference. It won't travel for longer distance. It will attenuate easily. Another voltage they will send us AC. There will be a transformer. From the transformer they will send to your house. Not avoid loss. The same problem is there in the signal also. If you transmit in the form of DC, it will be a straight line. It will be having a lot of external interference. Induction. So what you have to do? You have to convert that into alternating form of signals. So I have to transmit 1, 1, 1, 1, 1. How can I do alternating form? If I do alternating form, it becomes what? 1 and 0. So you have to apply a logic to include the transition from 0 to 1 or 1 to 0, even if you transmit continuous ones or continuous zeros. If you transmit continuous ones, the state will be above neutral. If you transmit continuous zeros, state will be below neutral. So you should not want to transmit as straight lines. You have to follow alternating type. How to induce that? We have to apply some logic. Interpret in different way. Interpret in different way. That different way of interpreting a signal is called signal encoding. In networks, wired networks, we might have studied various signal encoding techniques like Manchester encoding, differential Manchester. What is it there? These are various techniques for always alternating ones and zeros. there are some rules. Okay, interest of digital communications by William Stanley's booklet, signal encoding techniques. Now, wireless we have much more encoding techniques. We have amplitude shift key, frequency shift key, phase shift key. Based on the type of signal, we have digital signal as well as analog signal. So in what signal you are going to transmit data, based on this type of signal, you can apply various signal encoding techniques. Then the last is error correction. How to ensure the bandwidth is not wasted. How to ensure the bandwidth is not wasted? 1 gigahertz, 1 gigahertz comes in microwave frequency. If it is 32 gigahertz, it comes in radio frequency. And infrared frequency range is roughly the same. This is for local usage. This is for communicating with mobile phone. This is microwave communication with satellite. So we have different range of frequency for different type of communication. Again, the same thing. We have different links with different frequency ranges. So frequency regulation says that 9 kHz to 300 kHz is high demand because of local usage, and 2 unlicensed bands where others can use. Even you can see policemen using walkie-talkie with some frequency band where nobody else can use. This is free licensed band. So they have different licensing agencies around the world. So of course we need a transmitter, we need a receiver for receiving data. Both will have antenna and receiver send data. So transmitter, which is more intelligent device, transmitter, circuit or receiver circuit? Receiver circuit is much more complex than transmitter circuit because transmitter circuit will just transmit data, whereas receiver circuit will receive the data and interpret the data in the correct form. Moreover, in wireless environment, there are a number of obstacles are there. Suppose patient data, make it the signal, make it a wall, make it a small pinch, make it a tree, so it will scatter, and all those bits will be receiving in different time intervals. So I have to understand all the bits. I have to interpret. In wired environment, no problem. I will send a series of bits, series of voltage will be received. Wireless, the signals will be sent and will hit in different surfaces, scattering, reflection, shadowing, array. I have to collect. So the receiver circuit is intelligent circuit when compared to transmitter. Transmitter just transmits. The receiver is to receive. I can talk anything here, but it is very difficult for you to sit and listen and grasp what I have discussed in the right way. I don't bother whether you have understood in the same way which I have explained individually. But it is your responsibility to understand it guys. So receiver is intelligent circuit. So here we have the transmitter circuit by amplifier, mixer, filter, amplifier. While it is sending the data via the antenna. So this is a complex circuit which just you should know. It is not much important for MCA. So signal, you know, this, have you seen this equation? These are fundamentals of wireless. S of t is equal to AT sin 2 pi of t plus pi of t. That means a signal, a wireless signal component will have 3 components. One is called amplitude A, another is called frequency, another is phase. So if we try a signal, the signal will have all these issues. This is a signal. This is a signal. Now this signal will have amplitude. This is the amplitude. This is the frequency phi u. And at what angle it is starting. The signal can also start like this. Now this is the angle. So these are 3 parameters: frequency, amplitude, and phase. So it is represented as S of t is the signal, AT sin 2 pi of t plus pi of t. This angle we can change. So if you have one signal with one angle, you can have another signal with slightly different angle. Both can be same because both are different angles. I can have a signal with one frequency, another signal with different frequency. Both can be sent in the same channel. I can have a signal with one amplitude, another signal with another amplitude. I can send. So if I want to enhance the signal, I can enhance signal using amplitude, I can enhance signal using frequency, I can enhance signal using phase. That's why it is called amplitude shifting, phase shifting, and frequency shifting and phase shifting. VHAS, phase shifting. This is the main equation. It is used for doing all type of modulations in signals. So if you say a signal propagation range, it starts with a sender who is sending in data. Around the sender, There is a range, the range is called transmission range. There is a reduction range, there is interference. Otherwise, you consider this as a base station or tower. A tower is having coverage is now this much, for example. The area which is closer to the tower of a particular distance is called transmission range. It's called transmission. If you are away from the transmission range, you cannot able to transmit. Only thing is you can detect. Have you seen, noticed in the mobile phone, there may be 1 or 2 bars in the signal, but you cannot be able to call. So it is the out of this transmission region. If it is a reduction region, you may not be able to call, but you may receive calls. This is reduction region. If you go away from a tower to this interference region, you are not able to do both. Okay, this is the. So this area depends upon height of the tower, the device they have used, the amount of transmitting power they are using. Circuit to the thing. This is what is explained there. So the same thing is explained from the diagram where we have a transmitted power, we have signal propagation, and we have a noise. You know what is a, I said SNR, right? Signal to noise ratio. Signal to noise ratio is opposed to, if I send a signal, I am talking here, there are other noises also present in the atmosphere. Still you are hearing my noise, my voice. How it is possible? That is SNR ratio. SNR another. I have a signal strength. External noise is also having signal strength. If my signal strength is more when compared to that noise, you are hearing my voice. I am hearing some sound from outside, the AC is running there, I think. That noise is also there, but still I am able to communicate with you because my voice is more than that. So if the noise is also more, what will happen? I have to increase my voice. Therefore, the receiver has to apply SNR ratio. That is, I am talking about human communication. Even circuit also we have SNR, the same ratio. If we increase data rate, noise level also will increase. Suppose I am amplifying my signal, the noise also will get amplified. We have to apply appropriate device for removing the noise. Like, you can use an appropriate device for removing the noise. Amplifier is better, I got this. Amplifier will amplify the signal level of both signal and actual message signal as well as noise. Whereas repeater is an intelligent device which won't increase the strength of the noise, it will amplify only the message. We can use such devices for rectifying this. Attenuation, attenuation is what? When a signal is traveling for a longer distance, based on the distance, the level will go down. So if you want to increase the level of the signal, we have to use devices like amplifier or repeaters. Strength of signal falls off the distance over transmission medium. Attenuation factors for unguided media means wireless media. Receive signal must have sufficient sense so that the circuitry the receiver can interpret the signal. So if the receiver is not having sufficient signals, it cannot be able to interpret. Signal must maintain levels sufficiently higher than the noise to be received without error. So that's why if my voice is less than the noise strength, you are not able to hear my voice. So the receiver circuit also should be the same state. So the actual signal should be high when compared to the noise. Here noise refers to external interference. Maybe this noise, while the signal is traveling in the atmosphere, maybe from lightning, thunder, heat, all are noise noise. Now, I said various factors that can affect the wireless signal, right? Like shadowing, reflection, diffraction, scattering, diffraction. So if I send a signal from a mobile phone, it make it directly a ward. It make it a particle where the edge will reflect it back. It may give a particle where the particle may absorb and it will deviate the angle of the signal. Before signal button, it may deviate the angle. Scattering means it is just hitting the corner of a particular number plate or plate. It is just scattered. One button value potential. So like this, the signal gets scattered. Next is diffraction. Diffraction means what? If the signal is hitting a top tip, after hitting it, it may have multiple paths. So the receiver should be able to collect data which is coming after hitting the substance. Okay. So the receiver circuit design is much complex. For example, you take city like Hong Kong, where it has tall buildings, tall mountains, trees. Depicting a receiver circuit for such cities are very difficult. The world most complex circuit design for receiver is the complexity where it has ups and downs and a lot of things. We cannot emulate a tree's behavior. Simulation we can do. There is, for example, I am developing a software that deputes the behavior of a receiver circuit. I can put the parameter. Number one parameter is wall. I can mark thickness also. A wall is of 5 meter or 2 meter. I can mark any device, but I cannot mark a tree because tree will have different trees will have different characteristics. Name tree will have different movement, leaf movement. I cannot depict the behavior of a tree. So that's very difficult for designing a receiver circuit. You know what is there is a concept of rake receiver. Have you heard? Rake receiver means multiple bits are coming. For example, I want to transmit one bit, one and unknown. If I transmit one bit, if the one bit is facing a problem, what will happen? The entire data is lost. I am transmitting one bit. The entire one bit is lost. Data is lost. So what I am doing, if I want to transmit one bit, I am going to send a group of bits that can represent one. Group of bits that represents one. If these group of bits travel and they face all these problems, the receiver is able to receive certain number of bits in this group. The receiver should be able to identify these group bits represents one, not zero. Ultimately, what the receiver should do? The receiver has to understand the received data is not zero, it is one. Not zero, it is. So I want to go to a particular place. If I am going alone, if I met with an accident, there is a chance for losing my entire data. So instead of me, I am sending 5% or 10 persons. All those 10 will be a particular dress, for example. Let us say you are all wearing some shoes, the same color shoes. So, out of 10, 3 are not reaching the receiver. 7 is there. You count how many are having this dress. This color, 1, 2, 3, 4, 5, 6, 7. This 7 represents 1. If the value is less than 5, it represents 0. Some interpretation. Based on it, the receiver can represent. Still, it is not 100%. The max wireless transmission is always not 100%. Still, I can recover. At last, I have to finalize that I am receiving 1, not 0. On the decision now. They are applying. The CDM uses the same code issue. The code is used for dividing the bits into. If we have an issue or we want to skip it on the bill, okay? So I have only limited time to cover this course. This is called now. The overall concept is called multi-path propagation. Multi-path means what? After getting all these obstacles, all the bits will be traveled in multiple paths and it will reach the receiver in different timings. For a time the same different timings. The receiver should be collecting all. Signal can take many different paths between sender and receiver due to reflection, scattering, and diffraction. Signal is dispersed over time. Interference with neighbor symbols, interference. You know what is inter-symbol interference? Inter-symbol interference is if I transmit data, multiple users will transmit data in the same medium. Because of this neighbor signal, my signal will also get affected. This is called inter-symbol interference. The signal reaches the receiver directly and phase shift. Distorted signal depends on the phase of phase means for the angle. I explained. The signal can represent different angle. So if there is a distortion to a signal, the angle will differ. So if you differ the angle, with that angle, some other signal may be there. So both will have some problem. This is called distortion. This is about the fundamentals about wireless frequencies, how the wireless medium is prone for error. Talk about this infrastructure. So this diagram shows the infrastructure more and infrastructure less type of network where we have access points here. Two different networks. This may be a wide network or this may be another network. So if you want to communicate within this network, we need a centralized access point. So this node will communicate with the access point. This will in turn to communicate with another access point. Here access point refers to base station. If I want to make a call to you or call to my house, which is somewhere else, it will go to my base station, this will go to MSC, that MSC to another MSC, that base station, that base station, that node. This is how infrastructure network. If it is an infrastructure less network, running ad hoc means what? On the fly, I can form network. If laptop, if all are having laptop or all are having mobile phone, we all form an ad network. So if I want to pass data to the last person, I will pass data to your mobile phone, your phone will pass to that phone will pass to that phone. Like this is called ad network. So here there is no infrastructure. They will communicate with each other. So we discussed enough about wired and wireless. If both ends are neither at LAN, if both A and C send the channel to be ideal at the same time, they send this data at the same time. Other problem, if A is also sending the channel at the same time, C is also sending the channel at the same time, channel is ideal, both are transmitting at the same time, it ends up with collision. Collision can be detected at sender in the Ethernet. How collision can be detected at sender in the Ethernet? Because the channel is open. If he is also transmitting, he is also transmitting, his packet will be collide at some point. Because it may travel the same, it may travel the same. They may get collide. Because you are not transmitting a bit, you are transmitting group of bits as a frame. That's why the frame has to be of some size. For data network, the number of bits in the frame should be of minimum size and maximum size. Limitation. Why there is limitation? Because the presence of the frame in the channel should be known to other user. Therefore, frame in principle. The presence of the frame should be identified via Faraday's ABC system of If you have 100 systems, the 100 systems should know the presence of a frame from the first system. Therefore, the 100 systems should not transmit. If it is not visible, not will happen. Some point there will be collision. That's why there is a limitation in size of the frame. The frame size is too large, what will happen? Frame size of the rubber is too large. The amount of time it takes to load the bits into the channel will take a lot of time. So frame is 1 lakh bits in principle. All those 1 lakh bits I have to load into the channel. If I start loading all the 1 lakh bits per frame into the channel, the remaining systems will be idle. That's why there is a limitation. Bus the size that bus is number of seats in the bus is 57. They are like group bound. I can have a very big bus which is having 500 capacity also. Why there is no regulation that is permitting for having a lengthy bus of 500 seats? Yes. It will affect other users. That's the same logic. If you have a lengthy frame, it affects other users. They cannot be able to transmit because time is not good. If it occupies a channel, it won't keep on using the channel. It has to occupy for a certain time slot. Then it has to do this. There are techniques, time reduced multiplexing. This is wireless. Wireless collision detection is possible, whereas in wireless collision detection is not possible. For example, let us take A, B, C. A wants to send data to B. A wants to send data to B. C wants to send data to B. Now, A is sending a data. This data is available here as well as here. A is sending data to B. Now, B or A is not full of hope. C is also having a part here. Now, C is also sending data. A is also sending data. This data will be available in full B. But A doesn't know that B is going to send data because B's region is over here itself. So, in order to avoid congestion, the collision cannot be predicted because collision will happen here. If A is sending data, the data will be here. B, C is sending data, data will be here. Collision will be happening here and collision will be happening here. Now, if collision happens here, A cannot detect because A's region is over here itself. So, collision detection is not possible. But what we can do? We can avoid collision. How to avoid collision? If A wants to transmit data to B, before transmitting data, A should send a request to B saying that I want to send data. When B receives request, B should send a response message to both A as well as to C, saying that now A wants to send data to B. If C wants to send data, you don't send. This clearance agreement will be happening. After that only the data will be sent. This is called collision avoidance. That's why in wireless environment, collision avoidance is possible. Whereas in wired environment, collision detection is possible. CSMA CA here, there is CSMA CD. Another issue. For example, there is another node called D. If A is sending data to A wants to send data to B, and C wants to send data to D, give a problem. Another, if C wants to send data to D, the data will be there in B also. Actually, C wants to send data to D, not for B. Sorry, not for B. But still, if C sends data to D, since its coverage region is overlapping with B, this data will be available here. Since data is available here, if C A sends data to B, this will collide at this point. That may not be identified A. Because A is not having scope here. It is having scope only at this point. This boundary. Depend upon one. Again, the same issue. RTS CTS mechanism. RTS is request to send and clear to send. The request only there. This is for RTS. This is for CTS. When I receive CTS from my neighbor, it shows what? Somebody is willing to send data to the neighbor, therefore I have to wait. If I also transmit, what is will happen? That is very important. We call it as hidden terminal problem. This terminal is hidden from this terminal. This terminal is hidden from this terminal. That's why it is called hidden terminal problem. If I have another node, since C is exposed to B, C is not able to transmit to D, even though it is not transmitting to B because of exposing its region to B. This is called exposed terminal problem. Hidden na, this exposed na. Now C wants to send data to D, but still it is not able to. It is not allowing. This is called exposed terminal. So that is the main problem that can be solved by RTS CTS mechanism. The CSMA carrier sense and access. Collision detection is possible in wired. All aforementioned scheme can suffer from collision. Device can detect collision within while transmitting wait for no propagation delay. On collision detection, wait for random time before trying binary exponential backup algorithm. And wired, this is the wired. It is not for wireless. What is my binary exponential backup algorithm? If this is the channel, then systems are connected. If I want to transmit the data, I am sensing the channel is free. He is also sensing the channel at the same time. He also identifies channel is free. Both are attempting to transmit at the same time. It will collision. If I want to transmit the data, send the channel is free, don't send immediately. You wait for random amount of time. Again you set the channel is free, you transmit. Suppose the channel is not free, that means what? It is highly usable channel, so you wait for exponential backup. Wait for 1 second, check. Still it is not free, wait for 2 seconds, check. Still it is not free, wait for 4 seconds. Wait for exponential growth. 2, 4, 8, 16, 32, 64, 128 and back. Exponential backup. Why we are waiting for exponentially to ensure no collision. Collision is a development nashtam. Again I have to retransmit the problem. The binary exponential backup is exponentially backup in time. The hidden terminal problem say explained here. So we have 3 ABC. This region, the color of the effect of interference range. So if you overlapping region, both will have access to the problem. Solution is using RTS and CTS mechanism. So as I mentioned, you can send RTS. Suppose if A wants to send data, you will send RTS to B. This RTS will go to D also, both are neighbors. And B will clear by sending CTS will go to A as well as to C. Though C is not willing to transmit data, it will receive CTS, saying that for the time being A wants to transmit data to B, please you don't send any data. So once the CTS is sent, C will keep quiet, even though has data in the future. The time stamp how long game will transmit and the agreement level. So after that, the data will be sent. Components of IEEE 802.11, I think this is there in the syllabus. IEEE 802.11 is the basic wireless standard. And the components first component is mobile node. Next is access point. Group of access points in a region is called BSS, basic service set. Group of BSS is called ESS, extended service set. This extended service set will in turn connect with the distribution system to connect with the outside network. For example, your mobile phone is a landline call. You are calling from mobile phone to a landline. How is this possible? You now tell the path from your mobile phone, you are contacting the base station, access point. From the access point, it is not to be forwarded to another access point. It has to go to a landline. So no need to forward to another base station. It has to be forwarded to the backbone network. We call it as a distribution system. Distribution system is a unit which connects with outside network with different technology. For example, here the landline is India local phone, mobile phone to local landline, mobile phone to STD landline, mobile phone to ISD landline. Now, from your mobile phone to the access point to the distribution system via portal, it has to be connected with any other line, any other PST network, public system network. BSS is a collected number of systems. It is a ad hoc network now. Infrastructure less network now. This group is called BSS. If infrastructure based network now, mobile node access point, this group is called BSS. Basic service set, BSS. Doubt. BSS 1, BSS 2. So if two stations want data from this node to this node, from BSS 1 to BSS 2 now, this node can forward data to this node, in turn can forward to another node. Using this infrastructure network, I said the example, right? This is a BSS which is having nodes, stations 1, 2, 3, 4, any number of stations. I have an access point. It is connected with a distribution system. It is connected with a portal. If it is connected with another access point, maybe mobile to mobile communication. Mobile phone to mobile phone call. Suppose from mobile to landline or some other network, station to access point to distribution system to via portal to external 802.x. X means any type of network. In the architecture. I took the 802.11 architecture and diagram. Now, for this type of wireless environment, how the protocol stack is used? Protocol stack is used in all are same. Application, TCP, IP, logical link control, everything is same. Only thing is MAC layer and physical layer. What is MAC layer? 802.11 MAC. What is that? Data link layer is divided into two. One is the logical link control and MAC. MAC, half of the data link layer sub-layer is responsible for constructing the MAC frame, medium access control frame, and half of the layer is responsible for accepting data from the higher layer and passing this data to the MAC layer, MAC sub-layer. Now, 802.11 it becomes wireless. Now we have to construct a wireless frame. What is the difference between a wired Ethernet frame structure and a wireless 802.11 MAC format structure? Without difference, wired Ethernet frame structure to wireless structure. Wireless structure path from access point to another mobile node, access point, from the mobile node to access point, another access point, that access point to the node. If it is outside network, mobile node to access point to portal outside network. If a frame format will be different for wireless and different from wired. Wired, we have source MAC and destination MAC, direct communication. Whereas wireless, we have source node, access point, another access point, another source. புரியுதா? 4 இடத்துக்கு போயிட்டு வரும். So we need a separate MAC format. That's all. That also we will see.